Hello everyone. In this chapter we're going to talk about customized PCs and multimedia devices. Specifically, we'll talk about graphic workstations, audio and video editing workstations. We'll talk about virtualization. We'll talk about specific things you may want in a gaming PC or home theater PC. We'll talk about the differences in thick and thin clients. And then finally, we'll discuss some things you may want in a home server. So in thinking about a graphics workstation or a CAD or CAM workstation, these are optimized for graphics. These are used by photo editors. A lot of 3D printers will render their work on these to be sent to print. For these types of machines, you're going to want a very powerful processor. You're going to want a high-end video card with a high-end monitor, and you're probably going to want a motherboard with a lot of RAM. For the case, they mention that you may want room for multiple hard drives. Now that's kind of optional these days because hard drives are much larger than they used to be. You may also want a DVD or Blu-ray based on what you're opening or closing. And they mention a 750 watt PSU, though the size of the PSU would be dependent on the components in it. A lot of slides in this chapter are meant to make you think about specific things that machines may need for specific applications. And the reason that becomes important is that on the second part of the A+ exam, you may get questions where they ask you to give information about what out of a list of machines might be best suited for what application. And they want you to think in terms of things that are going to be used for graphics, that you're going to have a lot of memory and a lot of processing power. For an audio video editing workstation, you may have a specialized video and audio card. Chances are with a station like this, you're going to have a very large hard drive. And the reason for that is because when you are working with video editing, before videos are done what's called rendering, when they're in raw format, they're very, very, very large. For example, an unrendered Blu-ray can take up about 100 gigs or more of space on a hard drive for one single Blu-ray movie. Lots of these will also have 2 or more displays. That's so that you may be editing and rendering on one screen and then editing something else or working on something else on the other screen. In thinking about a virtualization workstation, here we mean a machine that's going to run virtual machines. And they say 8 to 16 gigs of memory depending on the number of VMs. That is completely dependent on how many VMs you're going to run at one time. There are lots of programs that do virtualization now. 2 that I like quite a bit are VirtualBox and VMware ESXi, or for a local machine, VMware Workstation. Basically, the idea of virtualization is that you run an operating system completely inside of a file that runs on top of your existing operating system. It's a great way to learn things about operating systems because you're able to do this without affecting your computer at all. If you try something crazy inside a virtual machine, you might mess up the virtual machine, but it's not going to affect your computer in any way. And with virtualization, very specifically, if you're going to do 64-bit virtualization, you have to have a motherboard that will support it. With just software, you can emulate 32 bits, but if you're going to emulate 64-bit, you must not only have a 64-bit machine, you must have a machine that will support hardware virtualization at 64 bits. By default, that's turned off in the BIOS in a lot of machines. I'm thinking specifically about Dell machines, for example. The machines we have in the labs were turned off by default, and we had to go in and turn that on. For gaming PCs, this is where you're going to find the absolute largest machines in most cases. And the reason for that is that a lot of these games now render such high-resolution graphics, they need super video cards to do this rendering. Lots of gamers will spend quite a bit of money on their video cards and on memory. The more memory and the higher end the video card is, generally the faster the machine will run. You may find that these machines will be overclocked, and to accommodate those, you might look at liquid cooling. One other thing that they don't mention here, but I'll throw in on gaming PCs and just laptops in general, lots of people are moving to solid state hard drives. Now, unlike a traditional hard drive that we've talked about, a solid state hard drive has no moving parts. They basically function like a USB memory stick, except they're internal and much faster. They're still much more expensive than traditional drives, though. So what a lot of people will do is boot a machine with 2 drives in it. I have a setup like this myself. I have an 80 gigabyte solid state drive that boots my computer and only has the programs I use all the time on it. Everything else is put on my 2 terabyte drive. And that way, when I need it, I can still use it, but it's not as fast as things that are on the solid state. For a home theater PC, something that you would probably have is surround sound audio, either a 5.1 or a 7.1 audio, 5 being 5 speakers, 7 being 7 speaker. Based on the inputs that are on your home theater equipment, you might want a sound card that has digital audio out with SPDIF. If you're going to use the PC as the only multimedia device, you're probably going to want one that has good audio and has HDMI out. That way it can go directly into your television. They mention HTPC form factors to accommodate small spaces. That varies from machine to machine, but I've seen lots of machines that are very small that are made specifically for home theaters that when you don't plan on expanding them, they come in a very small case. And that's a good idea based on the amount of space. They make devices that look like just a TV tuner that you might have. And you may have a TV tuner in your PC so that you can capture programs to it. So 2 other terms to be aware of are thick and thin client. And a thick client refers to just an off-the-shelf system. A thick client is basically a full computer. This might be something that you go to Best Buy and buy. These usually meet the minimum requirements for Windows. They meet almost always the minimum requirements for Linux if you want to run that. If you buy a Mac, that's a type of thick system because it runs completely on its own. These may act as standalone workstations, but in most cases now they're going to be connected to a network or the internet. And they're going to have some sort of onboard drive for local storage. Now that's in contrast to a thin client. And a thin client is a machine that is set up to run all of its applications from a network server. These may be small form factors. I have seen installations where thin clients are actually built into monitors, so there's no case or anything. You just have a monitor that's got a plug on it for a keyboard and a mouse. Most of these boot remotely. All that's on the actual machine is just enough of an operating system to boot it up so that it hits the network to do the rest of its booting. And the idea behind these, not only is it a security feature, but they're made to be a little more robust. Lots of these thin clients, especially the ones that are built into monitors, have no moving parts. They'll even put large heat sinks on the processors. They don't need much processor, but what little bit they have, they'll put a big heat sink on. That way there's no fans in it. So these are suitable for environments that maybe are dirtier or industrial environments where you wouldn't actually want to put a computer because of the heat or the dust or things like that. Another special type of machine might be a home server PC. If you have a couple of machines at your house, or maybe you've got an old machine and you want a place to store files, it's very common to make one of these, make an old machine at your house into a server. Usually if you're going to have a home server, what you're going to need is something that's got maybe space for a printer. You're going to want a large hard drive to store files on. They may have components such as a RAID array, multi-terabyte storage, and they mention maybe even gigabit network interface cards. We will talk more about RAID later, but RAID is a way to make your hard drives where if one dies, the computer will still run. And most motherboards now that are anywhere made in the last 2 or 3 years are going to have RAID support built onto them. So all you need is a couple of SATA hard drives to make that work. So in evaluating components on your motherboard that you own, or if you're looking at one for somebody else, there's a program you can run called MS Info 32. And this program tells you about the processor type. It gives you information on the BIOS, the OS, the amount of memory, and the components and drivers that are in use. Another place you may go is the device manager, and the device manager will show what's running locally. And then different software interfaces you may have that will tell you about the processes running. I like the manager built into Windows, the Task Manager. If you right-click and pull up your Task Manager, it'll show you everything that's running on your machine. For example, right now you see that I show Camtasia. I'm running some instances of Google, and I have Dropbox and our PowerPoint currently running. If I run MS Info 32, you'll get a screen that looks somewhat like this. It'll be different based on your computer. It tells you that I'm running Microsoft Windows 8.1, which was made by Microsoft. I have a 64-bit PC. I run an AMD processor with 4 cores. It tells me information about my BIOS. Down here we see that I'm running 12 gigs of memory in this machine, and I've currently got 7.8 gigs free. You can go down through this, run MS Info 32 on your own machine, and it'll tell you all about everything that's in your computer. Storage, for example, will show the hard drives you have in your machine. Here you see my fixed disk, my C drive that is a small drive. That's my solid state system. And then the D drive that I run with most of my programs on it. So in the process of installing and configuring multimedia devices, most of these are plug and play. What you will do is install the device, especially if it's USB, you'll just plug it in and the computer will detect it, and then if a driver is needed, it's going to ask you for that driver. One thing that I suggest, especially since Windows 8.1 is now out and some of you may be running it, you should always, when you purchase a new device, go to the website and see if there's a driver that's more updated than the disk that comes with whatever product you've purchased. For example, if you've bought a Logitech webcam, you should maybe go to Logitech.com and look it up and see if there are newer drivers than what came with it. And if so, download and use those drivers instead of the ones that came with it. That's especially a great place, are the manufacturer's websites if you're running a different operating system. For example, a Logitech webcam will work just fine on a Mac, but the CD that comes with most of them only runs on Windows, so you need to go to the actual manufacturer's site if you need the Mac drivers. You need to do that same thing if you needed drivers for Linux. So that is a rundown of some of the different specialized PCs that you may run into. The important thing here is when you're taking the exam, think about things that are needed on specific workstations based on what you're going to do, and the questions that you may see may have to do with memory or processor. Think if you're working with a lot of graphics or gaming, you're going to want very good graphics cards. If you're going to work with a home theater, you're going to want a really good sound card. And if they mention thin client, you really need pretty much next to nothing. Just a very, very, very low-end machine can be a thin client. All right, thanks for watching.